My name is David Mills, and with me today is Rob Barnes, and we're looking forward to talking about PKI with you all. So, there's a lot of stuff around PKI, but I'm assuming that most of you are here because you either manage PKI in your organization, or you have something to do with it, or you suffer from fallout when it's not managed correctly, or something like that. And so it's a big topic, and we're going to cover basically trying to modernize the way that PKI is managed. And so I'm going to start with basically talking about what PKI is. So apologies to the really advanced folks, but I want to just spend a minute providing some context because there may be some folks in attendance today who are not as knowledgeable about PKI, and I want to make sure that everybody gets as much as possible out of this session. So the next thing I'm going to do is talk about typical PKI management, and I expect there'll probably be a lot of nods and people that recognize this process because it's pretty broadly used and it's been around for a long time. And then once we talk about that and kind of some of the things that are challenging around managing PKI the traditional way, we're going to get into how we can modernize that process and manage that more efficiently. One, with using HashiCorp's Vault product. And that's something that we're familiar with and is used to centralize secrets management. And then Rob is going to take it away, and he's going to walk you through how you can actually configure HashiCorp Vault to work with AWS Certificate Manager, or ACM, and how we can do this and create these modern PKI management capabilities. So with that, I'm going to go ahead and dive in. And first just talk about what is PKI, or public key infrastructure. And basically it's procedures, processes, technologies, and standards that are used to manage digital identities and digital certificates. And that's for secure communication in a networked environment. So it's a huge part of cybersecurity, and it's a huge part of making things safe, communicating inside your organization and outside of your organization. And it's not always an easy thing to do, but we consider it a part of zero trust security when we talk about that in terms of managing secrets in general. So there's core components, some basic components to PKI. That is the key pair, or what you know as the public and the private key, that is used to secure communications between two endpoints and also be able to authenticate who it is or the entity that is sending the information to you using this capability. Next key component is the certificate authority. And the certificate authority, this is your trusted root certificate, and they're created by trusted third parties that generate and sign these certificates. And then the third part really is that digital certificate itself. And that digital certificate is used as part of that identification process and part of that secure communication. So the high-level processes are, we want to be able to authenticate unknown entities. And we do that with digital signatures, and we do that with those certificates. And then also we want to be able to use that public and private key to encrypt that communication. And so you've got secure communications going on between those two endpoints. And those can be between a laptop and a browser, or it can be to endpoints within the company, whatever it's being used for, mobile devices, IoT. And then last but not least, we want to be able to protect or ensure the protection of that data that's being exchanged. And with PKI, cryptographic hashes are used to do that. And so you can tell when the data is sent across and check to see if it's been tampered with by bad actors on the other end. And really, this whole end-to-end process using these core components is what comprises what's known as the chain of trust. And the chain of trust starts with that certificate authority, or that trusted root certificate that you use, and then actually goes to an intermediate certificate authority, or what's sometimes called the issuing certificate authority, and they issue a leaf certificate, and that leaf certificate is used to verify the identity of that endpoint where the data is going. And so all of that is the chain of trust. So an example of this, a pretty simple example, is when you try to log into a website from your laptop, you get a certificate from that web server. And when you get that certificate, that laptop is going to check your trusted stores for root certificates. And it's going to check to see whether that is actually coming from a secret or a certificate that's coming from a trusted certificate authority. And once it does that, your laptop encrypts a bit of data and using the public key, sends it back to the web server. And then if that web server is in fact the one that sent it and can read it, they're going to be able to decrypt it with their private key, and that's when you get the little lock up in the corner of your browser. And you can obviously click on that little lock in your browser, and you can see that certificate information in there, the public key, and other information.
Right slide. Yeah. Okay.
Yeah, okay. So yeah, sorry for the technical difficulties. Thanks, folks, for fixing that. I think my talking points were probably good enough for all of it, and this is kind of where we're getting into how PKI works, and just a quick diagram at the top. So very quick and dirty. There's a lot of complexities with PKI, how it works and managing it, but hopefully everybody's kind of on the same page in terms of what we're talking about. So at this point, I want to talk about what I think is considered a traditional way of managing PKI. It's coming from talking to lots of customers, just understanding a lot about how companies manage it today. And really, the challenges are that there's a lot of manual processes, there's a lot of different tools that are used, and it simply doesn't happen as quickly as it needs to happen. And I'll talk about that a little bit more. But what happens is you have an app developer that has a certificate that's going to expire, or they have one that's already expired and it's caused downtime, and they need to request a new certificate. So they go to their portal or their tool or whatever they use to request that that new certificate get created for their application. And then that is something that's going to be processed by the DevOps team. So the DevOps team, depending on what their backlog is like and all the other things they're working on, it could take a day to maybe 3 days to actually get that new certificate created. And of course, when they create it, they're going to have to update the key stores and the trust stores that are associated with that certificate. And then there is the networking team. And so they own the load balancers, other networking components that also need certificates. And because they're the only ones who have access, they need to actually submit requests to get those updated. So once all of those updates happen, like I said, there's manual processes involved in it. You have multiple teams that are going to be involved in deploying, testing, making sure everything works. So you've got ops, you've probably got teams that are doing QA on the certificates and making sure things work end to end, fixing anything that's not working. And then by the time that's done, then you can actually roll things into production. So there's a lot going on here. And based on feedback from customers that we've been working with, this could take up to a week just to get the new certificates, get things tested, and then get them pushed live. So not unheard of. In total, it can be up to 2 months of person hours a year that are spent managing certificates. And so at this point, I'm going to talk about a specific customer because I have some metrics around it and kind of what their environment looks like. But they are running 1,000 hypervisors across a public cloud platform. They're running on AWS. They're running things on premises, running about 1,200 services that are running on 20 VMs, running on the hypervisors. And they are managing, I think, about 4,000 certificates in total. And when they counted up how much time this was taking in the traditional process, this added up to those 2 months per year of actually managing certificates. So these are developers, these are other folks that have other primary responsibilities and probably would like to spend less time managing certificates, more time developing code and deploying new applications. So what actually came back from this conversation and a lot of the conversations that we've had with customers is we're working in a world where we have modern applications and services that we expect to quickly scale up, scale down. We want quick deployments. We're using CI/CD pipelines to push things out. We actually have very agile infrastructure because in a lot of cases, we're working in containerized environments. We're running in cloud environments. And the problem is that when you juxtapose this against something like the way you manage certificates or typically manage certificates, it gets really cumbersome and it becomes a blocker to being able to do agile development and be agile with your infrastructure and your application. So we're really living in an API economy. It needs to be about apps, it needs to be about pipelines, and it needs to be about machines and not humans. So expectations are that things will happen quickly when you need to renew a cert. The expectation is that it's not going to expire without you knowing about it ahead of time, having that certificate automatically updated, and then getting it pushed out into deployment. So with those expectations, this is a bit of a Trivial Pursuit moment, but if you think about when PKI was invented, it was invented by the British Secret Service, and I think the first paper that they wrote on it was 1969. And so this whole concept with the public keys, private keys, and how PKI works came a long time ago. Then, when the World Wide Web went public in '93, we found in around '95, PKI started being used publicly, and that was to create that secure connection between people that wanted to connect to the internet, connect to websites, and so forth. And the interesting part about all that is not a lot has changed in how PKI is managed and how things work in terms of the workflow from that time period until now. So if we're running all of these modern applications, modern infrastructure, we really need to update the secrets management process and specifically related to certificates in those environments. So where does Vault fit into the picture? It really addresses a lot of those pain points that we see in the traditional management workflows and tools. And there's increased agility because you're removing the human blockers in a lot of the manual processes to being able to get things out quickly and automated updates to certificates. You're reducing the risk because you're not going to end up with certificates that expire and you don't know about it until there's downtime. You're also going to be reducing the cost because you're automating things. So if you can automate the creation of the certificate or that renewal, automate it getting injected in the application or the endpoint where it needs to go, you're ultimately going to reduce cost because you're reducing the number of people involved and the time that it takes to actually make that happen. The outages, obvious because you're not having downtime for certificate expiration. And then increased security overall because you're automating things, taking the human error out, and you're making sure that things are happening automatically. And you're also storing secrets in a place with Vault where you have version control over it. So you don't have the versioning many times in the key and trust stores and where you're having to manually update things with your certificates. So what does modern PKI management look like, or what can it look like? We're using a tool like Vault. Really, Vault kind of sits at the middle of all of these processes. And you have secrets and certificates that are created when you need them. You get them injected where you need them on the application and the receiving end of that. And then you're also controlling access to those secrets and the management of them, not by multiple teams, not by multiple tools, but from one place, and you're using identity access management to control that one focus point. And so if you have outages or other things, your blast radius is very well known because you're centralizing where you're managing those secrets and those certificates, and you're also automating the way that you're doing it. And speaking of automation, the Vault agent template or things like Acme, Vault supports the Acme protocol, or other ways to automate certificate management and deployment and renewal, you will be able to automatically authenticate with Vault, and it's token-based to make sure you have a secure connection, and whatever machine or user that's accessing it is approved to have access. You can apply policies, things like ACLs, to anybody that has access to Vault to be able to manage things. And then you're automatically going to be able to have a new certificate created before the old one expires and have that automatically injected into the endpoint in the application. And then you can automatically re-authenticate with Vault or have the agent do that whenever that time period comes up. So you're controlling things like the lifetime of that certificate. Doing things the old way, certificates tend to sit out there for a year or more than a year. Some of that's intentional, but really a lot of it is because it's such a pain in the butt to manage them, you don't want to create short time to live for a certificate and have to do it all over again in a month or 3 months. So you're creating them as needed, and then they're deprecated when they're not needed anymore. Some of the recent enhancements in Vault, Vault's done PKI management for a number of years, but we're always updating the capabilities based on customer feedback, market need. One of the most recent releases contains support for the Acme protocol. So you can configure Vault to operate as an Acme server, work with common Acme clients that are out there like CertBot, so that you can automate things that way. There's also a version of Vault that if you're a federal government agency that needs to be compliant with FIPS 140-2 cryptographic standards, you can use that version. And then also OCSP for certificate revocation in addition to CRL, which is often used. And then there's other enhancements like being able to support multiple CAs, internally, externally, that connect to Vault, and using Vault as an intermediate CA. And then last but not least, we've created the ability to run a service for customers that want to customize data that they have associated with their certificate. It could be for business needs or it could be for compliance needs, but they're able to do that with Vault and use the SEEP service to do that. In terms of hierarchy, it's extremely flexible. So like I mentioned, Vault kind of sits at the center of secrets management. It's easy to integrate with, but also the way that you can develop the hierarchy can match your workflows in the company or however you need to configure it. So it can work with as a root CA in a private environment, functioning also as an intermediate CA. It can also work with an external CA. And this is a common situation where you would configure Vault to just be the intermediate certificate authority. And once again, you're assigning roles to those intermediate CAs in terms of who has access, what type of access they have, policies, how you want to set the time to live on your certificates, et cetera. And you can have multiple intermediate CAs. So the example of the customer I mentioned earlier that was running multiple workflows and managing about 4,000 certificates, they're using a couple of intermediate CAs in their environment with Vault. And so they have one that's just servicing their websites and their services. They have another one that's servicing those networking components in terms of generating the leave certificates and automating that process. And so you can configure it in a way that makes sense for the workflows that you already use and how you need it to be configured. In terms of scalability, Vault is already extremely scalable. So a single PKI node can do thousands of requests per second that it processes, but you can always add more standby nodes. If you're using Vault for multiple different types of secrets management, you can create a dedicated PKI cluster for Vault in terms of performance. You can beef up the standby nodes, increasing the hardware, the CPU, all those normal things you would do to scale something up. And then you can also take into consideration geographic location, where you're putting the clusters that makes most sense for your PKI management. In terms of integration, we have a lot of partners that we integrate with, and you'll see just a few of them here. We obviously function as an Acme server if that's required in your environment. We also support manual and automated workflows, so extremely flexible from that point. And anything that wants to access Vault or manage secrets within Vault is going to be authenticated on the front end, so extremely secure there. And then also things like key management can be offloaded to HSMs or other stores that you might want to use to manage it. So the integration capability is extremely flexible. And I was going to say, going back to the customer, I just want to share some data with you. The customer that was managing things the traditional way and taking roughly a week to update things 2 months out of the year, once they integrated Vault with their environment and their workflows, they were looking at possibly a total of an hour to update all certificates once they kicked things off by pushing a deployment. Just because things were happening in an automated way, you're taking human error out of it. It was just much more efficient, and that's, magnitudes of order much faster than what they were doing before. So with that, that's kind of how Vault fits in the picture. We kind of talked about PKI, some of the problems that people have with it. I'm sure some of you share some of those pain points. And at this point, I'm going to hand it over to Rob. And Rob's going to talk about and kind of walk you through how you would integrate Vault into your environment and how it can work with something like ACM. So Rob, take it away.
Thank you so much. And good afternoon, everyone. Thank you, David, for explaining PKI so eloquently. So it's my role here now to try and bring what David has explained to life with a bit of a demo, right? So at a high level, what we're going to do with this is we are going to have a root certificate authority, which is going to live in AWS Certificate Manager, and we are going to set up Vault as an intermediate CA that's going to broker those certificates on behalf of our root CA, right? So we're going to walk through the whole architecture of how we're going to set this up. We're going to use Terraform to do this. Can I just get a quick show of hands in the room? How many people are familiar with Terraform? Fantastic. Fantastic. Let's crack on. So at a high level, we are going to be using something we call HashiCorp Cloud Platform. Now, HashiCorp Cloud Platform is it's Vault as a managed service, amongst other services as well. But in this case, we're talking specifically about Vault, right? And in order for that to work, we have what we call a HashiCorp virtual network. So this being AWS reInvent, I'm going to make the assumption that most people here are familiar with AWS VPCs. A HashiCorp virtual network, or HVN, as I'm going to call it from this point onwards, is basically a VPC, right? And the Vault cluster that we're going to deploy is going to live within that HVN, right? On the AWS side of things, we have our VPC, we have private subnets, and within our private subnets, we have our workloads. And it's these workloads that are more likely going to need our certificates that are signed by our intermediate certificate authority, right? So essentially, for that to happen, we have a peering between our HVN and our VPC. So it's kind of two sort of private networks. And this allows us to have Vault able to communicate with our private workloads without having to go via the public internet, right? So that's a very sort of high level of how this is going to work, right? So you're all familiar with Terraform. So we're going to start from the beginning. The first thing we want to do is we want to deploy a VPC, right? We're using the AWS Terraform provider. I'm sure you're all familiar with that, seeing as every single hand in the room went up when I asked about Terraform, which is great. So the first component is we want this VPC. So we have just our Terraform code here. We have a seeder block, which is giving us a /16 address space, and we're calling it main. There's probably better names for it, but I'm not great at that. And then within this VPC, we want to create a subnet, right? So this is going to be a private subnet. This is using a /24 address space within sort of that /16 range. And we're going to call this subnet private. So there's nothing special here. And this is where you would deploy your workloads naturally. Right? Now, jumping back to the image that we had before, now we talked about the HVN, that basically being a VPC, right? So we're going to need to deploy that. And now to do that, we're using a different Terraform provider. We're using a Terraform provider which we call HCP, and that's what interacts with the HashiCorp Cloud Platform. And the specific resource we're using this time is the HCP HVN resource. Now, this supports multiple cloud providers, but specifically we're talking about AWS today. So we have to tell the resource exactly what cloud provider we're using, so that's AWS. And we need to give it a name, which is calling a HVN ID, and we've called it AWS reInvent. And just like every other resource in Amazon, it will live in an AWS region, so we have to give it an AWS region here. I'm from the UK, so I decided to go with EU West 1, right? So it's quite simple setup for what you're used to with VPCs and subnets, right? But then this is where the magic really starts to happen, right? This is where we start to do the peering, right? So peering happens from two sides. It's a three-step process. The first thing we want to do is we want to initiate this peering connection. So we have a resource in the HCP Terraform provider which facilitates this. So we just need to give it a few pieces of information, right? So we need to give it the ID of the HVN that we've created. So we're just using, as you can see on the screen, interpolation from the previous resources that we have created. We also need to give this peering that we're initiating a name, right? We're calling it a peering ID, and we've called this one main. As you've probably established by now, I'm not great at naming things, but we move. We also need to give it the ID of the VPC that we would like to peer to, So the first resource we created was that VPC. We're just giving it the ID for that. And then there's some other information we need to give, like the actual account ID that owns the VPC and the region that it lives within. So we're just using Terraform data sources and information like that to configure this resource here. So that's the first step of setting up our peering between our HVM and our VPC. Now, step 2 is from the AWS side of things, right? So we want to accept that peering connection request, right? So we have this acceptor resource. It's very straightforward. We're literally giving it the connection ID, which we're interpolating from the peering request we've just created, and we are setting it to auto accept, right? And then the third and final step of setting up peering is to create a route. At the end of the day, this is all networking. You need to establish routes in order for traffic to know where it has to go, right? So we have this resource under the HCP provider, which is the HVN route. And essentially, we are just going to give that route a name. We're going to give it the destination CEDAR, which matches the same address space that we had in our VPC on AWS, the /16 space. And then we're going to give it a target link, which is the network peering self-link when we initiated the peering connection. So you put all of these things together, and this is what's going to allow a Vault cluster that's deployed to your HVN to communicate with your private workloads that are in private subnets within your VPC. And the final kind of building block of the foundations of this demo is actually deploying the Vault cluster, right? So if anyone here has worked with Vault before, deploying a Vault cluster yourself is quite an involved process. I have done it many times over the years. But now, just in a few lines of code, I can deploy a Vault, managed Vault cluster to our HVN, and we are pretty much good to go, right? So we're treating this as one part of the stack. This is kind of our foundation Terraform, right? So we have this resource, which is HCP Vault cluster. We give it a name, production. I probably should have called it PKI, if I'm being brutally honest. And we want to tell it what the HVN ID is that we want to deploy it to. And then we have things like tiers, right? So if you're going to deploy a managed Vault, there are different size Vault clusters and different capabilities that you can deploy to. If you're a small organization, there are tiers that you can do which are a bit more relevant and make more sense for your scale of organization. Or if you are a large enterprise, you may want bigger clusters, or you might want more disaster recovery sort of features. So whatever the tier is, we have a complete list of tier information that you can look up. If you decide to go down this route, you would select that. We've just gone with standard large for demo purposes. And finally, there's this lifecycle block, which, because you're all Terraform experts in here, as I've ascertained, you'd understand that because this is such a critical piece of infrastructure, we don't want any destroy operations that are accidentally run to take out this cluster, because it will be catastrophic if our workloads cannot get their PKI certificates, right? So that's literally the foundations of how we're going to set up this demo. So you have these things in place. It allows us to move to the next piece of the building block. So we talked in the beginning about what it is we were trying to do. We're trying to have AWS Certificate Manager act as the root CA, right? And then we want Vault to be the intermediate CA, sort of issuing certificates on behalf of our root CA, right? So to anyone that's not well-versed with AWS Certificate Manager, it's capable of doing a number of things, right? It can provision and manage and deploy public and private SSL or TLS certificates, and you can use that for your AWS services, or you can use it for services external to AWS as well, right? From my own personal experience, I used to have a website, devotsrob.com, and it was actually AWS Certificate Manager I was using for TLS for my website. So it's something that many people are using. It's pretty cheap to do as well. Right? The other thing it can do, like I said, is it can act as a private certificate authority. Now, when I first started using AWS Certificate Manager, this wasn't a capability it has, but since then they've added this. And this is what we're going to utilize for our demo, right? So essentially, this is going to act as our root CA. So how does this look in terms of our Terraform code? we're back to the AWS Terraform provider. And the first thing we want to do is we want to deploy this certificate authority, right? So we're giving it a few pieces of configuration information here. So we want to give it a key algorithm. So we're using RSA 4096. And we also want a sign-in algorithm for the private key. And we're using SHA-512 with RSA. DevOpsRock.com is the subject name. Every certificate needs a common name. So we're just using that as an example. And in terms of the certificate authorities, there are a couple of types that you can deploy with AWS Certificate Manager. You can either do a root CA, which is what we're doing in this case, or you can do a subordinate CA. Right? So sort of when you think about subordinate CA and intermediate CA, you know, it's one of those things that I've asked sort of 10 different people, like, what's the difference between the two? And I've gotten 10 different answers. Sometimes people use the terms interchangeably. Sometimes there are subtle differences between the two. We're not going to get into that for the sake of time, because that's a debate in itself. But essentially, those are the two types that you can deploy with AWS Certificate Manager. In our case, we're going with root. And there's a nice little failsafe that is provided as part of this feature within AWS, which is the permanent deletion. Right? If something were to happen and you were to delete your root CA by accident, or you intended to delete it, but then you realize, oh, I shouldn't have done that because A, B, and C, instead of permanently deleting your root CA, it kind of deletes it, but you can reverse that operation up until, in this case, 7 days later. If we had set that to 30 days, it kind of gives you a 30-day grace period, which allows you to restore the root CA to all its previous splendor and glory. Right? So that's the first resource. We have our certificate authority. Right? Now, it doesn't really do much without a certificate actually being issued for there. So we have another resource, which is our private CA certificate. And we're issuing that certificate for our root CA. So again, a few pieces of information that we need to give here to configure this. So we need to give it the ARN of the certificate authority we have just created. And then we need to give it details of a certificate sign-in request, which is actually created by a different resource, which you'll see in the next step. Right? Something I want to point out to you is this template ARN. This is something I had to do a bit of reading up on. So essentially, when this CA is going to issue our certificates, it's going to issue it out according to a template. Right? For a root CA, the way that we've laid out this template is how you would do it. We're using the data source to figure out the current partition of our AWS account. But essentially, you would follow a pattern that's quite similar to this, and specifically in there it says root CA certificate /v1. And that's what denotes what we would use for our root CA. And then we have to configure the validity of the certificate for our root CA as well. We just use 1 year. You probably do something a bit more sane in production for yourself. But this is a demo just to show you how this works. Right? Now we need to actually create the certificate authority certificate linking. So basically what we're doing is the certificate we just created, we need to associate that with the certificate authority that we created before. Right? So we're just giving it those same pieces of information, certificate authority ARN, we're giving it the certificate we just created, and we're giving it the chain of the CA as well, which is all interpolated from the resources that we have just created. And completing these steps here will give you the ability to start to issue out certificates from this root CA. Right? So that's kind of our second building block. So we've gone through the foundations of getting Vault in place and getting our VPC in place and setting up communication between the two. We've deployed Vault to that. We've now gone to AWS, and we have set up a root certificate authority. Now we want to look at how we could configure Vault to act as an intermediate certificate authority for the AWS Certificate Manager root CA. Right? And it's sort of a 4-step/5-step process. Right? So the first thing we need to do is we need to create a secrets mount within Vault. To anyone that's not familiar with Vault and how it works inside, essentially Vault is a very pluggable application. You enable the things that you need it to do. You don't have to enable things that you're not going to use, right? So it makes the runtime a lot more efficient. So essentially, if you want to use Vault for PKI, well, you would enable PKI on that. If you're not going to use it for that, then don't enable that. Just you enable the things that you want to do. So PKI comes under what we call a secrets engine. So we want to enable the PKI secrets mount. Then when we've done that, we want to create a certificate signing request from Vault. And that certificate signing request is what we're going to sign with our AWS root CA's private key. And once we've got that certificate, which is signed, then we can set that within Vault. And that's what's going to allow it to start to issue out certificates on behalf of our root CA. Then finally, we need to create a Vault role. And a Vault role, it just sets a series of sort of boundaries and parameters for which you can deploy certificates. So you might say you want to do subdomains as part of this role, or you don't want to allow subdomains, or maybe you want to allow bare domains. It's entirely up to you how you create that. We'll look at that in a bit more detail, right? But let's start walking through our Terraform code to configure these things here. So as I said, the first step is we need to create a Vault mount. We're doing this using the Vault Terraform provider. If anyone hasn't heard of that one before, believe me, it's life-changing. It's a lot better than writing bash scripts. So we have our Vault mount resource under this Terraform provider, and we're giving it a path, which we're calling PKI. We can call it anything we want. We can call it staging PKI, production PKI, whatever you want to call it. But what we can't compromise on is the type of mount. And the type of mount is a PKI secrets engine, so we need to specify that. Then we have some optional things that we can do. So we can put an optional description there. This is a PKI mount, is what I've put. And then you have some lease information. So in Vault, how it issues secrets is via leasing. So essentially, if you have a short-lived secret, let's just say an AWS credential that it generates on demand, that will have a time to live associated with it. And then when that time to live expires, then Vault will go in and revoke that credential. So when we talk about the default lease, this is kind of the default sort of time to live. Again, these numbers are probably not same for PKI, but this is just a demo, so that's absolutely fine for this purpose, right? So you can set your default lease, and you can set the max TTL lease that you would allow under this mount as well. And then we have the next step. So we want to create a certificate signer request under this PKI mount that we have just enabled. So we need to give it some basic pieces of information, right? So essentially, we want to make sure that we're creating a certificate signer request based on the PKI backend that we've just done. So we've given it the backend information. The type is internal. This is an internal kind of CA that we're doing. And the common name is the same common name that we set up for our root CA. So we've put devopsrob.com. Right? And then the type of key that we're going to use is RSA, which is similar to what we've done with our root CA. So with this resource, it's going to give us a certificate sign-in request, right, which is what we're going to need for our next step. This is very basic PKI workflows. Now, we want to issue another certificate in AWS, right? And this certificate is going to be for our intermediate certificate authority within Vault, right? So it's a similar resource to what you saw me do before when I was creating a certificate for the root CA, only this time we're doing it for the intermediate CA. So the information we're giving it this time is the same root CA ARN, but the certificate signer request we're providing for this cert is the one that Vault has generated, right? So we're taking that certificate signer request, and this resource is going to sign it using our root CA's private key, right? And then if you look at the template ARN, this one is different to the last one that we saw when we did the root CA. So the key difference here is you can see that instead of it having root CA/v1, now we have a subordinate CA, right? Or a subordinate CA certificate. And it's important that you get this part right. Otherwise, it's not going to be able to issue out certificates that are actually working properly. And then, just like we did before, we configure some validity information, right? And then what we have to do is we now need to associate that certificate that results from that. So basically what we've done is we've taken the CSR from Vault, we've signed it with our private key from our root CA, and what results from that is a certificate. And we want to give that certificate to Vault and say, hey, here you go, this is what you're going to use to act as an intermediate CA, and that will allow you to start issuing certificates on behalf of AWS Certificate Manager. And then the final step in terms of the Vault configuration side of things is to create the role that we're going to issue certificates against, right? So we're going to create a role called subdomains, and the idea is that we can create subdomains under devotsrob.com. So, we could do david.devotsrob.com or whatever the subdomain would be. So we're just putting some basic configuration in there. We're basically telling it the PKI backend that we've created. We're giving it a name, and we're giving it some parameters to operate within. So we are allowing subdomains to be issued under this role. We're also allowing localhost. I'm not sure how sane or insane that is. That's for you to decide. And then the allowed domains that this role is allowed to issue certificates against. And obviously, devotsrob.com is the allowed domain, right? If you have more complicated PKI setups, that list can grow as long as you need it to grow. And then we're giving it a TTL. So any certificates that are issued against this role will have this TTL there. And that's it. We're now ready to consume our secrets. We're ready to get these certificates issued via Vault on behalf of our AWS Certificate Manager, right? So let's take a quick look at what that looks like in practice, okay? So here, if you've never seen Vault before, Vault, you can interface with it in a few different ways. There's a CLI, there's an API, there's a UI, and we have several SDKs. I thought for this demo it was easier to give you a visual representation of what's going on. So here we have the Vault UI, right? And if we look at this here, we have our secrets engines that we have enabled listed on the side. The one that we're specifically interested here is the PKI secrets engine. So when we click on that, that will take us to our PKI dashboard, which gives us information about our PKI installation. So here you can see things like the issuers. We've created one issuer with our Terraform code. We can also see the roles that we created. Again, we've only created a single role here. And then from here, you can do a number of different things. So you can issue certificates against specific roles you created. If you've already issued certificates out, you can view information about these certificates as well. And then if you have an ID of a specific issuer, you can type that in there and you can view it in there. Right? But let's have a look at the roles tab here. So we created that role called subdomains. So we'll click into that and have a quick goose. And here you can see things like the role name, which is subdomain. The issuer is default. There's only one issuer, so that would be the default anyway. If you have multiple, you can configure that differently. And any certificates that are issued under this role are subject to being backdated by 30 seconds. So that's just how this is configured. We don't actually have a max TTL configured for this. If you remember the Terraform code, we didn't specify that. As a matter of fact, most of the options you see with a dash in there means that we did not configure anything for that, right? So it's going to go with the default settings there. You can see that we do not allow bare domains because we didn't configure that. You can see the allowed domains as well. It's basically all the stuff that you saw within the Terraform provider, right? So let's head back to our dashboard, and then we'll take a look at the issuers. When that clicks in there. And here we can see we have our issuer that we've created. And you can see the tags at the bottom. You can see that it's an intermediate certificate authority. And you can also see that it's also the default issuer for our PKI installation here. So we'll just click into that and have a quick look. And here you can see the intermediate CA certificate. You can also see the entire CA chain certificate as well. You can copy that and paste that into a file if you need to. And then you see some basic information like the common name, the issuer ID, some very basic stuff. If you wanted to interact with Vault for this issue, you can copy the ID and do some things with it with the CLI or whatever it is you want to do. And then we have the SANS information, which is basically the common name, in this case, devotsrob.com. And here we have the validity here, right? So obviously this is pre-recorded, so you can see the dates backdate a little bit. But that is valid for a period of just under 10 days. And the other cool thing about this is, for the purposes of the time, we didn't configure it, but you can actually configure a certificate revocation list distribution points. So when you revoke certificates, where it pushes that information out to. So that's pretty much our issuer setup and what that looks like. So we would just scroll to the top when this video catches up with my speaking, like now. And we'll go back to our PKI dashboard, and now we are going to issue a certificate against our subdomain role. So we'll just select that subdomain role, and we'll press the issue button. So here we have this form to fill out, so we need to give it a common name. And for our common name, we're going to put in there reinvent.devotsrob.com. Remember, this is the subdomain role that we're using, so we're creating a subdomain. And we're going to give it a TTL, and we're going to give it a TTL of 30 minutes in this case, right? And just the way I do things, the private key, I prefer it in PEM format. That's just the way I do it. And we hit generate, and that gives us a certificate. So the key thing it's telling you at the top here is the private key that's been generated here is only going to be available to you once. So take it down now or lose it forever, right? So you have the certificate that is actually generated there, so you can copy that and paste that into a file to do stuff with it, which we will do. Or you can download it if you like, but we'll actually just copy it out and paste that into a file. And you can see the common name of this certificate is reinvent.devotsrob.com. Every certificate has a serial number, a standard PKI stuff, so the serial number's there. You can see the CA chain, the issuing chain, and the all-important private key that if you don't copy it down, you will lose it forever, right? So this is pretty much our certificate issued. Now let's take a quick look and see what we can do with that, right? So we're going to switch over to our terminal, and we're going to paste that into a file. So we'll just echo that. This is basic Linux commands. We'll echo that into a file. We'll just paste. And we'll call this file, I think it's called reinvent.crt. Cool. So that's our certificate locally on our machine. We'll just clear the screen really quickly. And now what we can do is we can have a quick look at our CA chain certificate, right? So a CA chain certificate should chain the whole root of trust together in one file. So we'll just have a quick look at that, and you'll see in there we have at the top of it the AWS certificate for the root CA, and then you have the Vault certificate for the intermediate CA, and that is our chain, right? So that's the CA that we're going to verify the certificate against. So we can run this OpenSSL command to verify our cert. We're going to verify it against the CA chain.pem file, which is what we've just inspected, and we will give it the file name, which is reinvent.crt. And when we hit enter, you can see that everything is A-OK, right? So that means that it's been able to verify that that certificate is in fact signed by that entire chain of trust. So it's signed by the root CA on behalf, so it's signed by the intermediate CA on behalf of the root CA. And that's basically Vault issuing out certificates for our root CA in AWS, right? Yay. Thank you. I always thought I had to be my own cheerleader, but I appreciate it. So what we've done is a very ClickOpsy way of doing things, other than the Terraform. Terraform, I like to think that's quite DevOps, but in terms of how I demonstrated the actual certificate being issued, that was quite ClickOpsy, and yeah, that works for trying to quickly grab a certificate to put in a certain place to try something out or whatever it is. But for production-hardened operations, that's probably not the way you're going to do things. David made reference in his presentation to getting the certificates you need where you need them, when you need them, right? So Vault gives us the capabilities to basically do exactly what David said. We can either use something called Vault Agent, which is another process that runs alongside Vault. Essentially, that can take care of authenticating to Vault automatically for your infrastructure or your applications. You can do this via token or other auth methods. And it can request the certificate, and it can write this using the templating function. It's got to a file locally that your infrastructure can read. And it can also take care of renewing that certificate. It can make sure that the Vault token that you have is always up to date. So if that expires, it can renew the Vault token, so you always have your permissions to be able to read that cert and be able to issue it where you need it to go. You can also do a similar thing with console template, which is another tool that we have Vault Agent's probably the way to go for something like this. You would probably have this on your infrastructure, but it works just as well with console template too. Right. So I'm just going to summarize everything David and I have spoken about today. I know it's been a long presentation, so I want to keep it front and center of your minds. So David elegantly expressed to us what PKI is and how it works, went through some use cases, even brought in some customer examples of how people are doing PKI. He went through some of the common challenges that are encountered, again, using some of the customers he's speaking to as a reference point, and how we can try to solve some of those challenges by modernizing our management of our PKI deployment. And then in the end, I showed you how we can use Vault to act as an intermediate CA for our root CA within AWS, right? Now, I hope you found that useful. If you would like to do some further reading or learn some more about some of the concepts that we've discussed today, please do take a picture of these QR codes that we have on these lovely screens either side of me. There's documentation, there's some white papers that you can read, and there's some more information about Vault with AWS Certificate Manager. Right? I'll leave that on the screen for just a few more seconds, and with that, I would like to thank you so much for your time, your patience, and listening to us, and I really, really do hope you found David and I's talk useful. Thank you so much.